Hello, mechanical engineering government job aspirants. Welcome to our channel Engineering Educators. Engineering in an engineered way. I am Milan and today I am going to discuss the VIZAG Steel Management Trainee 2017 Mechanical Engineering question paper with detailed analysis and solution. So now go to our question part. The first question from the technical section is the variance theorem of moments states that if a number of coplanar forces acting on a particle are in equilibrium, then the right option for this question will be answer D, as the variance theorem states that the algebraic sum of moments of two forces about any point in their plane is equal to the moment of their resultant about that point. Now go to our next question, that is the moment of inertia of a square side A about an axis through its center of gravity. So it's a short question, we have to remember these values as this is the important for engineering mechanics and also strength of material. So we all know the moment of inertia of a square about an axis either x or y is equal to a to the power 4 by 12. So the right option for this question will be answer C. Now go to our next question, that is the angle of inclination of the plane at which the body begins to move down the plane is called option A angle of friction, option B angle of repose, option C angle of projection, or option D none of these. So the right option for this question will be angle of repose, as from the definition of angle of repose we say that from this diagram you can also understand that the angle alpha is called the angle of repose and is equal to the angle of friction when the body in this condition of limiting equilibrium on an inclined plane. That is, when the friction angle phi will be equal to this inclination plane angle alpha, then the body will automatically begins to move down from the plane. So then the angle will be called as the angle of repose. So the right option for this question is option B, angle of repose. So now go to our next question, that is the coefficient of friction depends upon option A area of contact only, option B nature of surface only, option C both A and B, and option D none of these. So to answer this question we must know the laws of static friction, where it states that the friction force always acts in a direction opposite to that in which the body tends to move, and frictional force is directly proportional to the normal reaction between the surfaces. The frictional force depends upon the nature of surfaces in contact, and the last point, that is the frictional force is independent of the area and shape of the contacting surfaces. So then from these laws, four laws, we can say that the option A will not be right, because the coefficient friction does not depend upon the area of contact only, then the right option for this will be the option B, nature of surface only, as it directly comes from the laws of static friction. So now go to our next question. The force applied on a body of mass 100 kg to produce an acceleration of 5 meter square per second. So this question is also from the Newton's second law from the engineering mechanics, and we know the Newton's second law, that is the F is equal to ma, where F is unknown and mass and acceleration are given. So from this equation, if we put the value of 100 kg into 5 meter square per second, then F will be 500 Newton. So the right option will be option C. The units we have to must remember the units, because the Newton is equal to kg into meter square per second. Okay, so now go to our next question. Next question is, if tension in the cable supporting a lift moving downwards is half the tension when it is moving upwards, then the acceleration of the lift is. For this question, we have to first assume that when the lift is moving upward, then the tension in the cable is T1, and when the lift is moving downward, then the tension in the wire is 0.5 T1. Now apply the Newton's second law. In both the cases, we get two equations, T1 minus mg is equal to mass into acceleration, and the equation for the lift when moving downwards, it will be mg minus 0.5 T1 will be equal to mass into acceleration. This acceleration is unknown and we have to find the acceleration. So from these two equations, we get the value of acceleration is 1 by 3 g. So the right answer for this question will be option B, g by 3. Now the next question is, a rubber ball is dropped from a height of 2 meter. If there is no loss of velocity after rebounding, the ball will rise to a height of. We have to apply the collision equation, and we know the coefficient of restitution E is equal to under root of small h by capital H, where small h is the rebound height and capital H is the ball dropped from a height. So as it has given it no loss of velocity, so we have to use the coefficient of restitution E as 1, and from this equation we get the value of small h as 2 meter. So right option will be option B. So our next question is the Poisson's ratio for steel varies from. We know the Poisson ratio is the ratio of lateral strain by longitudinal strain, given as the nu, and generally the value lies between 0.25 and 0.34 for most of the metal. So the right option for this question will be option B, 0.25 to 0.33. Our next question is, when a load on the free end of a cantilever beam is increased, the failure will occur. So it is the free body diagram of the cantilever beam, and we know the bending moment will be maximum as the fixed end. So due to the maximum bending moment at the fixed end, there is a chance of failure will occur at the fixed end, because due to the bending moment there will induce a bending stress. If the bending stress value is greater than the design criteria of the material, then the beam will be failed. So the right answer of this question will be option B, at the fixed end. Our next question is, the pressure, dry bulb temperature and relative humidity of air in a room are 1 bar, 30 degrees Celsius and 70% relative humidity respectively. If the saturated steam pressure at 30 degrees Celsius is 4.25 kilopascal, then the specific humidity of the room air in kg water vapor per kg dry air will be. So this is the question from the refrigeration psychometric process, and we know the specific humidity ratio or absolute humidity or specific humidity omega is equal to 0.622 into PV by P minus PV, where PV is the partial pressure of water vapor and P is the total pressure, and we all know the Dalton's equation as the total pressure is equal to partial pressure of air plus partial pressure of vapor. Also we have to know that the equation relative humidity phi is equal to PV by PV sat. Here the relative humidity is given as 70%, so we can write 0.7 is equal to PV, and PV saturation is given as the 4.25 kilopascal. So from this equation we got the value of PV as 2.975, and by using this value we put the value in this equation and got the value of omega as 0.622 into 2.975 divided by total pressure. We know that the 101.325 kilopascal minus 2.975, and by calculating this we got the value of 0.0191. So the right option and the right answer for this question is option C. Here you can see that without using this calculator we have to calculate these values, so we have to practice it very well for calculating this kind of equations or this time of calculations. So our next question is, when a shaft is subjected to a twisting moment, every cross section of the shaft will be under shear stress, because we know due to the twisting movement there induced a shear stress in every cross section of the shaft. So the right answer will be option C. Our next question is, the slenderness ratio is the ratio of, we know from the Euler's critical load condition equation, we got this equation, and where this term LE by K minimum, where K minimum is the least radius of gyration, this ratio is known as the slenderness ratio. So the right option for this question will be, slenderness ratio is the length of column to least radius of gyration, option B. Our next question is, the columns whose slenderness ratio is less than 80 are known as short column. Generally short column or strut, they have the slenderness ratio up to value 40, and the long column for slenderness ratio has up to 120, but generally we can take up to maximum the slenderness ratio maximum up to 80 for short column. In different books you can find different values, but generally these values 40 and 80 are taken for the short column. Okay, so our next question is, a cylinder contains 5 meter cube of ideal gas at a pressure of 1 bar. This gas is compressed in a reversible isothermal process till its pressure increases to 5 bar. Then the work in kilojoule required for this process is, we know for reversible isothermal process T will be constant, and for the isothermal process we know the equation P1 V1 is equal to P2 V2, and the work done for isothermal process is P1 V1 ln V2 by V1. From here V1, P1 and P2 is given, but the V2 is not given for this equation, so we have to find the value of V2 from this equation, and by putting this value, V1 as 5 meter cube and pressure is 1 bar, and here is pressure is 5 bar, so find out the V2 as 1 meter cube. So by using this equation we get the P1 will be 100 kilopascal into 5 into ln V2 is 1 meter cube and V1 is 5 meter cube. So we have to know the value of ln 1 by 5. So we have to remember this value 1 by 5, or we can also say that the by ln 1 minus ln 5, and we know the value of ln 5 will be as 1.609. 609. So we have to remember this value, and by calculating this equation we get the value of 804.7 kilojoule. So we have to calculate this without using any calculator. So just for this we have to practice it very well without calculator for the exam. Now our next question is, in order to have maximum power from a Pelton turbine, the bucket speed must be. So we know the hydraulic efficiency for Pelton wheel as 2u capital V minus small u into 1 plus k cos phi by v square, where capital V is the jet speed and small u is the bucket speed, and phi is the angle of the bucket at outlet tip, and k is the constant we just get. So for the maximum power transmission we have to differentiate this equation with respect to bucket speed du. So by differentiating this we get the value of maximum bucket speed will be at half of capital V, that is the jet speed. So option here will be option B will be equal to half the jet speed. So these are the 15 questions that are discussed in this first part. The next all questions will be discussed in few parts. Thank you for watching this video. If you like this video, please like, comment and share with your friends.